And that's one of the reasons why PlanetScale is so good, because if you look at what this product fundamentally is, it's SQL. SQL has existed for, I think, 50, 60 years, something like that, and they didn't remake SQL. They didn't make a new database query language. They didn't make a special new thing. They just used SQL, something tried and true, but then they innovated on it. They took that foundation and they built on top of it. They added these branches. They added the deploy request. They added the serverless. They added the scaling. They added the DX. And now suddenly they have this wonderful thing that we can now use to build really cool stuff ourselves. That's what I want to hammer home, is that you want to build on top of stuff. Stop trying to reinvent the wheel. Best advice I could give myself from 3 years ago. The way we deploy our apps is fundamentally changing. For years, the standard was always to set up custom AWS, GCP, or Azure configurations, to build out a terraform file, to set up Docker files, to add K8s, add auto scaling, do all this really fancy stuff, stick a load balancer on it, do everything that you'll see in a lot of tutorials and videos. But that's sort of outdated. We are now living in an era of one-click deploys. We're living in a world with Railway, with Vercel, with PlanetScale, where deploying a database, deploying your app, deploying your backend is as simple as logging into Railway, logging into your GitHub account, clicking on your project, and hitting deploy. We don't live in the era of you have to learn all these configurations anymore. And to all the new devs and rising devs out there who are working in web development, backend development, front-end development, whatever, I want to recommend that you, instead of spending all your time trying to learn AWS, GCP, Docker, all these things, they have a place, but they don't have a place in what you're probably going to be doing. What you're probably going to be doing is trying to build cool stuff. You want to make stuff that works. You want to make an app that runs, and you want to put it in production. You want to show it to people, and you want to make something real. And all these new solutions that are coming out help you make stuff that's real. That's what I want to show you today. I want to show you the ways you can use these new services to make stuff that's real, and show you why you should not be thinking about Docker anymore. You shouldn't be worrying about Terraform anymore. You shouldn't be worrying about what's at the bottom. It's time to just worry about what's at the top and to build cool stuff. New devs don't need to learn this. Just use what's built and build on top of it. So the first thing I want to show you is the databases. Here I just have a basic mapping of AWS, Amazon RDS. There are 3 alternatives I picked here. There are a million more. Railway even has alternatives to this, but these are sort of just 3 I picked that are kind of different. Supabase is a managed Postgres provider. They also do more stuff, authentication, that kind of thing. You can learn more about that if you're interested in it. Personally, I don't use it, but I know a lot of people who do, and they really enjoy it. Now, the 2 that I'm most familiar with, and the reason I picked them, is MongoDB Atlas and PlanetScale. My company actually uses both of these, and I've used both of them a ton, and I really, really like both of them. So PlanetScale is a serverless SQL provider. It is built on top of, what's it called? Come on, I should know this. Vitesse. It's Vitesse, isn't it? Yeah, it's Vitesse. Yeah, Vitesse. PlanetScale is a serverless database provider built on top of SQL and using Vitesse to auto-scale horizontally, and it's a really great provider that turns your database into a pseudo Git repo. It's really cool. It's the only one I really need to show you here, and that's just because of how it works. So right here, a little bit of a leak, but this is the database for Insider Biz. This is our user management and payment management stuff. I won't show any details of it, but what you can see in here is I have this branch category. So right here is main. Main is what's actually running in production. So this, if you go to insiderbiz.com and log in, your information will go into this main branch. But I also have in here this dev branch. So inside of here, this is what I can use to develop locally, and I can create tests and run things locally, do schema migrations and that kind of thing. And then, just like a Git repo, when I want to take it to production, I do a deploy request. So it's just like a pull request, but for your database. And I love this pattern. It is so freaking cool to be able to use your database intuitively the same way you would use a Git repo and match the 2 up with each other. So this has gone miles, it's miles ahead of any of the AWS, GCP, Azure products that you would see for database management or database creation. You can't add branches to an Amazon RDS instance. You can't do anything crazy like that, but here you can. And this is the sort of thing that the new devs of this new generation have access to. The last generation has built all of these tools that we can now build on top of. And something I see a lot of people trying to do is reinvent the wheel. And I'm fully guilty of this myself, and I'll kind of tell that story later. But All of these things now exist, and it's up to us to build cool stuff on top of them to actually make something useful instead of just making the same thing over and over again. And that's one of the reasons why PlanetScale is so good, because if you look at what this product fundamentally is, it's SQL. SQL has existed for, I think, 50, 60 years, something like that, and they didn't remake SQL. They didn't make a new database query language. They didn't make a special new thing. They just used SQL, something tried and true, but then they innovated on it. They took that foundation and they built on top of it. They added these branches. They added the deploy request. They added the serverless. They added the scaling. They added the DX. And now suddenly they have this wonderful thing that we can now use to build really cool stuff ourselves. That's what I want to hammer home, is that you want to build on top of stuff. Stop trying to reinvent the wheel. Best advice I could give myself from 3 years ago. But so PlanetScale, it's all about the relational side of things. When we get into MongoDB, MongoDB Atlas it's built by the company that makes and manages MongoDB. And what MongoDB Atlas is it's just a managed MongoDB provider. My company uses it. We use it to store all of our financial data, our trades, forms, that kind of thing. The reason why we pick MongoDB is because we have a data set that works for documents. We love the aggregations, love the syntax, works beautifully with our server language of choice, which is Go. I have another video on this that kind of discusses this in more detail. But yeah, MongoDB Atlas is excellent, and while you could potentially provision your own instance on AWS, use a managed one. Let them manage it for you. Anytime I have an issue with my schema or I need an index or something, I get an alert from MongoDB. They just send me an email and I'm like, oh, okay. I go in, do what it tells me to do, and it works again. I don't have to think about this. I just have to think about building something good. Supabase is the same idea. It's kind of just new Firebase, if you're familiar with that. I don't use it personally, but I know a lot of people who do, and they really, really like it. It works great. It's basically just Postgres with some features on top of it, authentication, storage, yada yada. Now, the next two things I want to talk about are EC2, which is basically just cloud compute instances, just renting a computer in the cloud and running something on it, and Lambdas. Both of these are notoriously difficult to set up and use. While at their surface, conceptually, they're not too complicated, actually working through and managing in AWS kind of sucks. Because while it's a great service and it does great things, it's built for enterprises that are handling billions of dollars and doing insane stuff with teams of thousands of people. And more than likely, you're not doing that. If you're watching this and doing this sort of thing, you're just trying to build something cool and learn how to actually use these technologies. You're not going to gain anything from learning how to do OAuth management on AWS. What's the point? So what these do is these allow you to get those same capabilities, an EC2 instance, which is basically just a computer running in the cloud, and a Lambdas instance, which is a serverless instance, which, if you're not familiar with serverless, it's pretty much the thing that makes TypeScript viable and one of the best things that's come out in the past few decades. And it is effectively auto-scaling, where anytime you make a request to a server, it spins up an instance, executes the request, then kills the instance. And this sort of pattern allows you to theoretically scale infinitely, no issues, no hassle, pay for what you use. Fantastic stuff. And the two examples here I have are Vercel and DigitalOcean Functions. I know this is kind of a weird one, a little out of left field, but I actually use DigitalOcean for some stuff. I use them for our cloud storage bucket. I guess it's another thing I could potentially include in here, but that's a more niche use case. S3 is still good, but it's kind of just another abstraction on top of S3 to make it nicer. But they have DigitalOcean functions, which are very simple and easy to use, effectively Lambdas. They're just serverless functions that you can invoke by calling them and actually deploying them instead of having to set up a Dockerfile or zip them and then upload them or set up some crazy CI/CD workflow. You just link your GitHub account, click deploy, and it works. It's fantastic. And then Vercel, of course. Vercel is where, if you're building a front-end app, Next.js, Nuxt.js, Svelte, whatever, this is almost certainly where you're going to be deploying, and for very good reason. Vercel uses Lambdas under the hood. When you provision your Next.js app and you get that output where you see I have /API/v1/API/v2, any of these different routes, those are each getting provisioned their own Lambda under the hood, but you're not the one who's provisioning that. You didn't have to go through and spend hours setting up a way to go through and pick out a Lambda and build it for each method within your Next.js app. Vercel did that for you. That's no longer a concern. Your only concern is actually building the app, which is what you should be worrying about, not worrying about how do I deploy my code. deploying code shouldn't be a bottleneck anymore, and it's not. That's what I want to show here. So then the final one that I want to talk about is Railway. Railway is something that I've kind of come across recently, and I really, really like Railway. There's something that's just nice about it. It's very new. It came out in 2022, and it's basically Heroku, but DX'd up to be more modern. So it's the same sort of idea of you can just deploy instances really easily, but they deploy really fast because they use Nix packs, and they're also insanely easy and intuitive to manage. They just kind of work how you feel like they should work. It's hard to explain. And in order to explain it, I want to show you an example. So what I'm going to do here is I'm going to set a timer. I haven't practiced this, I haven't done this before, but I am just going to start a stopwatch, and I'm going to see how long it takes me to create a new API and get Hello World working and deployed on Railway, and just show you how easy it really is to use these things these days. Deployment is not scary anymore. It used to suck, it doesn't. So let me show you why. So just starting here at 0, just start it, let's test. So I'm going to start, I'm going to go to GitHub. I'm going to create a new repository. I am going to call this railway-hello world, and then I will make this public so you can see it. I will add a git ignore for Go, because I'm going to do this in Go. I'm going to add a readme license IT. So I've set up all this stuff. I'm going to create it. I'm going to clone this real quick. We're going to see out of here. This. It's spelling railway right. It'd be really embarrassing if I was spelling railway wrong. Yeah, I spelled it right. Let's go. Okay. So we have this clone, we have this built, so I'm gonna go mod init. Or whoops, go mod init, and then let me give it the right URL. Bam, bam. Get rid of the HTTPS. Just created a basic Go package. Let's go ahead and create main.go. Let's do go mod. Let's use my personal HTTP framework of choice, which is Go Fiber. So we'll just use Fiber, and we will go to the docs, make sure install it. So we just go get this. So we will go get Fiber v2. And then now all we need to do is set up this simple Hello World app. I won't cheat and copy it. I'll make this somewhat realistic. So package main. So then we will do func main. And inside of here, we are going to create Fiber instance. Fiber colon equals fiber.new. Thank you, Copilot. And then the next thing we need to do is set up a GET request. So we'll just do app.get and then /hello. And then we will do comma func, just pass an anonymous function. And then we want to do c fiber.ctx. This is where we can get our information about the parameters and send stuff. And now all we need to do is c.send, and then instead of hello world, I'm just going to say back here, this needs to be fiber. Now finally, all we need to do is just start up our server. So now we just do start server, and then we want to list it on 3000, except it's a little different because since we're deploying this, we need to listen to the correct port. So what I'm going to do instead is I'm going to say port equal os.get env port, and I'm going to say if port equals empty, then I will just say port equals 3000 else, and then now we can just do excellent. What are you mad about here? It didn't auto import the wrong one. That's why it's mad. So even with that incredibly scuffed experience of me not being able to read basic documentation and redeclaring fiber twice, because we are good at developing things here, I promise, we're already done in 5 minutes. So if I just do go run main.go, and then we can just test this locally. Really? Still, I swear, I know what I'm doing, I promise. I'm not this dumb. Sorta. Okay, so all we need to do is just http // local host 3000 slash, and then we do hello world. So it works. We have this very basic hello world app, which took longer than it should have, but that's okay. Because the point is not the fact that I cannot write a hello world. The point is that we can deploy this hello world really easily. So I'm going to do git add-a, git commit, or let me tidy, get rid of the unused imports, and then git add-a, git commit -m, created app, git push. Alright, so this is already up on Git. Now we just need to deploy this to Railway. So how are we going to do that? All we need to do is go to Railway itself. Now we are going to go ahead and make a new project, deploy from Git repo, and then it will pick it. So I think it just can do this. Where is it? There we go. So I just needed to give it access to my personal projects. I hadn't done that before. So this project, we called this Railway MP Railway Hello World. Boom. Deploy now. No variables needed. We can go ahead and do this. So this has been clearly a very sort of scuffed setup for actually building this. I made a bunch of mistakes. I've done a bunch of stuff wrong, which is deliberate because I wanted to show you what this actually looks like instead of just a polished, I went through and I practiced this 10 times and then did it perfectly. This is what it really looks like. You go in and it's this simple. It's really as simple as, oh, I didn't have it in there. I need to log in, authorize it, give it access to my Git repos, and then suddenly it's right here. So we need to go ahead and settings, we need to enable this. So we need to enable it to have a domain. So then now if we go out to here, it's not found, then /hello, it's not found. In a moment. And now we do hello. The domain has provisioned, and just like that, we have world. So with very little effort in, let's see what the final time is, 9 minutes and 18 seconds. That was it. I have a full Hello World app deployed. That could not happen on a lot of these past things. This couldn't have happened on AWS or GCP or any of these things. And I actually have a story to back this up, which is a little bit of a tangent. The main information's done. If you're done, thank you for watching. Have a great day. But the sort of reason why I want to talk about this and why I think this matters is the very first site I built way back when I was in high school was I deployed a website for a restaurant. I knew the owner well, we had a good relationship, so he contracted me and my friends to build a site for him. And we did. It worked, and It was so over-engineered, it is not even funny. We set up a massive custom GraphQL backend, and we set up a crazy Next.js front end, and we did all this stuff and made it super complicated for a restaurant site that needed to display a location, some pictures, a menu. It should have just been a static site. But we over-engineered it because we didn't know what we were doing. We had all these tools and we were super excited to use them, so we just went for it. So we over-engineered it was our first mistake. But then really where the mistake came in was how we deployed it. The way we deployed it was so bad. I deployed it to what's called Google App, I think it's GCP App Engine. GCP App Engine. Let's see if I can find this. Yeah, App Engine application platform. I was deploying to this. And look, it works great, it's fine, and maybe it's improved over the years, but this is not Railway. This, in order to deploy to this, I had to set up a custom Dockerfile because you had to containerize it first. So I had to containerize it, and then upload it, and then add my environment variables, and do all this stuff. The UI was super complex. I did not really know what I was doing for sure. I didn't know if it really worked, and it took me days to get this working, and there was a deadline, so I was scared. So I was working day in and day out. I was 18, had no clue what I was doing. Spent all this time trying to deploy it, all this crap, all this time, and then when we finally did deploy it, it kind of sucked because we didn't have the right amount of things actually provisioned to it. We tried to do the same thing with the Next.js app, and it would barely load the home page because we were deploying it to this app engine and it was running all these serverless functions, not serverless. It was running it with a real server, but we only provisioned it a really small amount because we wanted to actually like conserve costs and stuff because we were scared of paying for that kind of thing. We didn't know how to do it. And then it was terrible and we were really worried, and all these things happened and it barely worked. And at the end of the day, we were just in over our heads because we were trying to deploy something in a way that we just shouldn't be. We shouldn't have been worrying about Docker. We shouldn't have been worrying about, I mean, I guess we didn't know about Terraform at the time, and I've heard of it, but I've never actually used it, and truthfully, I don't think I will. I don't have a reason to. I work on building stuff. I'm not a infrastructure guy, unless, of course, you want to make the next railway or whatever, in which case, yeah, have fun in AWS land. More power to you, and we appreciate the things you make. But the point is, I didn't get anything. I ended up with a worse experience. I ended up paying more, and I ended up creating a much worse product by trying to over-engineer it. You think that if you get fine-grained control, you can get more out of it. You think that, oh, if I can get down in and minutely manage everything one bit at a time and manage all the environment variables and carefully tune my CPUs, you don't have the expertise and you're not going to get any benefit out of it. Your to-do app with 3 users, 2 of which being you, why? Why are you deploying it like this? Learn the concepts and then just put it here. Do what we did here. This was so easy. This was 9 minutes. I went from nothing. I spent like 3 minutes playing around with Go because I'm an idiot, and then we got it up live, and then I didn't even do the live thing correctly. I had to go in and fix my GitHub. If you had this down, it would happen instantly. And then when we get into billing is insanely cheap. They have a great developer platform. All you have to do is they have very fair usage. You go in here, you can see, okay, my current usage, and this is my actual company's site, the Insider Viz Forms API. We're going to end up using 65 cents. Now, a lot of that is owed to Go being so fast and us abusing, well, it's not abusing, it's using the framework the way it's supposed to, but using static building for Next.js. We build our pages every 20 minutes, so we're basically doing a few API calls every 20 minutes, and goes insanely quick, so our usage is very low, which is great. And you can deploy all your stuff, all your backends right here like this. And if you want to do the same thing with a database, it's as simple as dirty jail. I guess that's what they called it. All I need to do is just give it a database and then add one of these. It'll give me a connection string and I'm up and running. I have a database done. No management, no crap. It just works. So this has been incredibly long-winded. If you've made it this far, I greatly appreciate it. But I hope you get the point, which is just don't reinvent the wheel. Too many people do it. I'm guilty of it. Every new dev, you get all these tools and you sort of end up going up this, you get up the competency curve and you're like, oh wow, I can do all these things. I've learned what Docker is. I've learned what all these, I can do this stuff. I can use AWS, and you just try and use everything you can when you should be using the stuff that already exists. So if you learned anything today, use what exists. I think this is a pretty good example of things to just start with, and this concept doesn't just apply to databases, EC2 instances, and Lambdas, email providers. Payments is a huge one. If you try and roll your own payment provider, you're a psychopath. Use Stripe or Shopify or whatever. If you want to deal with the regulations on that, have fun. You won't. So learn all those, use this stuff, and build cool stuff. Thanks for watching. Have a great day.